This video is on probability distribution, and I want to get to see how to handle questions under that particular topic in statistics. Well, we have the question 1 there that's saying the random variable x has a PDF, that's a probability density function of probability of x there being 1, 2, or 3 as shown below. So the random variable x can be 1, 2, or 3, showing us that if it's 1, the probability is 0.1. If it's 2, the probability is 0.6. If it's 3, the probability is 0.3. And okay, as follows. Calculate 1 e of x. What do they mean by that? That's just the expected value of x, and there's a formula. When you just see e of x, there's a formula that you need to use in probability distribution. So this is how you know that you're dealing with a question on probability distribution. You just see such things, e of x, maybe they'll ask you variance of x. So let's solve it. Well, when you're taught e of x, what they actually mean is x multiplied by p. Summation, by the way, sorry, summation of x multiplied by p. We know that x is taking on a value 1, okay, a value 1, as you can see there, and then multiplied by the probability that was corresponding with it. So like 1 was corresponding with 0.1, and then 2 was corresponding with 0.6. So that's what they mean. And then it's a summation of x times p. So each x value multiplied by the probability, then you get your answer, as I'm about to show you actually on the next screen, the answer to the first part. Well, I hope you can see the computation of part 1 of the question. E of x is equal to the summation of xp, and then you do what I've just demonstrated. You're multiplying every x value by the probability, and this one gives us an answer of 2.2. Let us solve the next one. The next one is asking for e open brackets 3. What do they mean? This means that this time around we are going to be multiplying every probability times 3, because it's like x has taken on the value 3. That's what they mean. So when you see in those brackets where there is usually an x value, it's like they've told us that now this time around x will just be 3. So all the probabilities in the table will be multiplied by only these 3, as you will see on the next solution. Let me show you. Well, if you get to see there on the solution, we have e of 3 calculation. You've seen where whichever probability, the probabilities are 0.1, 0.6, and 0.3. We are multiplying each and every probability by 3. It's like x has taken on the value 3. So unlike the first part, which was just every x value with the corresponding probability that it had, this time around it's like x has taken on the value 3, and then it's still being, and they are being asked for e. What does e stand for? E is the expected value. And since it's still the expected value, we know we need to be multiplying x times p. But just be careful on x. On x, we just substitute 3 only as we multiply with all the probabilities, as you can see there. That's the approach. Part 3 is asking for e 5x. This time around, as we said, where there is x there, they've put that expected value of 5x. How can you answer this question? Well, expected value, right, of 5x. As I said, whenever you just see this e, what does it signify? X is multiplying p. That's just the reasoning that is there. When you just see the e, it's expected value. Now, take note. X e over 5x, meaning it's like when you're substituting in this formula there, it will be like before you put on the x variable, start with 5, because like the x has got a coefficient 5. That's how you interpret that. So 5, and then now x, the x values, remember your table is looking, there was that x is equal to 1, 2, and 3. Remember your table, right? So it will be like in the first part 5 multiplied by 1, and then the probability here 0.1, which was corresponding here. If you remember, 0.1 was just below there. Then you got the next one plus 5. Again, always 5 should start, because like 5 is the coefficient of x. 5, what's the other x value? 2 now. Since it's multiplying there, there's a 5x, so it's multiplying the 2. What was the probability on 2? 0.6, and so on. Okay, then you even find your answer. Yeah, then there's a shortcut. You can just express this like this: 5x. They've just said expected of 5x. Huh? Well, you already know the expected value of x when you computed it separately in part 1. So they just say, according to the rules, we had found actually 2.2. The rules in probability distribution state that when you're given maybe finding the expected value of maybe x that has a coefficient, like in our case, just go and substitute this answer you found here, because it's like you already know the value of the expected value of x. So you can just say 5 multiplied by 2.2, which should give you 11, which is as good as what I was just about to show you, where you multiply the long cut of 5 multiplied by 1, 0.1. If you rewind the video the way I was trying to start it there, you'll still get the same answer. Someone who just got there and substitute the expected value of x having been found and just put it there in the formula. Next part. The question has now asked for expected of 5x plus 3. This one I'll equally just show you a shortcut. When you just see expected value having maybe the coefficient of x with some other stuff, there's just a shortcut, and I'm about to show you. So in this case, they're saying, okay, expected value of 5x plus 3. Sorry, there was no bracket there, so just like 5x plus 3, meaning on x, and in short, since they're talking about expected, the fact that there's this e in front, then wherever there is x, it would not be wrong to just go and substitute the answer that you had found as the e of x, because it's just telling you that the expected value of x is 2.2, meaning wherever you see x in any other scenario like this, you can just go and put it, because you've already found that value of the expected value of x. So wherever it appears in a form of equation type of scenario like this, just go and put it in. So it will just be like this, plus 3. The answer is what? 14. Done. So just get to use those rules and apply them. Yeah. Part B is asking for x is a random variable, the number on a biased die, and the PDF of x is shown below. X being 1 to 6, as you can see there, those are the values that x can take on, and then the probabilities of the corresponding numbers, as you can see in fraction form. Calculate 1, the value of y. How do you find the value of y? Well, yeah, there's a missing probability. That's something. Let's establish one common ground. Y, the y they are looking for there, is a missing probability value. How do you find maybe a missing probability value amongst other probabilities? Well, we only remember one rule. All probabilities add up to 1. So we can use that rule, solve for the value of y, as you will see on the next screen. Well, have a look at the computation on the screen. You add up, as I said, all probabilities add up to 1. That's the property we're using. So you sum them up, including the y, which is unknown. Then you solve for y in that same theory that we have just taken up here. So you just do that, make y the subject, and you find that here it gives you what? 1 over 10. 1 over 10, you can even express it as a decimal, as what? 0.1. That's all. You've answered part 1. That's the value of y. So whenever there's a missing probability, remember this rule. The next part of the question asked for e of x. Again, it asked for e of x. Let me show you the solution. Well, that's the answer there, just below, e of x, just like we learned earlier on in the first part of the question there. When you ask for e of x, what do they mean? X multiplied by p. Summation of x multiplied by p. The x values were 6. There was 1, 2, 3, 4, 5, 6. But as we said, how do you multiply x by p? Each x value with the corresponding probability below it. So here there was 1 as the first x value. The probability below it, there was 1 over 6. Plus 2. 2 was the corresponding one, 1 over 6 again. 3 corresponding 1 over 5. Just like that, just keep multiplying, but then you add. That's how whenever I just thought e of x, remember it's summation of x times p, just as we stated earlier on, if you remember the video. How about this other row? You'll see it in the next part. This other row here is summation of x squared. What do they mean? Well, it's equally straightforward. Let me show you. So before we go to the solution, let me first demonstrate what they mean by e of x squared. Remember, as I said, whenever you just see e, what is the formula? X times p. Let's understand this common ground first. Now they've just said on x, make sure you square. That's what this rule means. So it's just going to be like x square, then p. You just proceed the normal procedure. You're still multiplying x by p, but just remember on x, square it first. So if x is 1, you say 1 squared times p, whatever p value will be, that's the probability. So now let me show you the solution and you make sense out of that expression. Well, if you look at the screen there, you're able to see the computation of what I said. I even expressed it. This just simply means summation of x squared p. Then you do just like that. You know, the values of x, there was 1 up to 6. So you square the first value of x, 1 squared, multiplied by the probability that was just below it. 2 squared is the second value of x, 2 squared, then again multiplied by probability, just like that. So it's a rather easy approach. It's just following the steps as this video is outlining them. That's basically your probability distribution. That's just how you know you're answering a question of probability distribution, asking for E of x, what and what not. Part 4 is asking for variance. That's variance. That's abbreviation. Variance of x. How do you find the variance of a probability distribution? Well, there's a formula as well. So they say when calculating variance, it's summation of x squared p minus, this is actually a broken down formula by the way, of xp. So summation of xp, remember this is how you find E of x. Then at some point you just square your answer. For example, the way we're getting E of x is 2.2. Then you just come and square the answer. So what they mean by that, when you've done your computation of E of x, then just come and square the answer. That's how you interpret this side we have boxed. The other side, I'm sure, is self-explanatory. From the other part, we're just from solving x squared times p. So every x squared, every x value, you square it first and then multiply by p. Then just subtract the 2. Then you're done. That's how you find variance. This is just the simplest way you can break it down, actually, that formula. Yeah, then, yeah, so let me just show you how you're going to do it in the question. Well, that's the computation. So I already did up the summation of x squared times p as of even the previous question. That's 15.23. That's the answer that came out when I summed up every x squared times p, every x squared times p, just like that. I got 15.23. Then I now subtracted from this other side. I said summation of xp, which is just as good as E of x, the way we solved it. Every x value, just every normal x value times p, then you sum them up. That was the 3.5 we got. I think that was part 2 of this same question. It gave us a 3.5. Then now you square. That's what I mean. Now you square that summation now. That's what you do here. And then you can solve for variance. That's how you solve for variance. So just remember the 3.5 we had gotten earlier on as the E of x value. It's basically what they were even expressing here, x times p, you sum up, then now square your answer. That's variance. So basically that's a formula broken down as explained as well. How about the other one? Variance of 4x. What do they mean by that? That was the last part of this question. 4x. Well, there's just a property you need to know about in probability distributions. Variance of maybe a given what? Coefficient of x, okay, just is solved as follows. Are we clear there? Variance there, if you want, you can actually even repeat this same part of the video. Variance of any given coefficient, and then they put x, is just solved as follows. You just square that coefficient and multiply it by x. And which x are you multiplying? The variance you found. Because remember, when you just see this expression, variance of x, then it gives you an answer like we got 2.98. Meaning, wherever they'll ask you variance again, wherever they'll ask you variance, it's like you now, wherever they ask you maybe variance of maybe 10x, whatever, just not on x, you're substituting this answer you got because it's still relating to what? Variance. Just like we're doing to the other one, expected value. Whatever part that would have a coefficient, whatnot, but it's still under expected value, you can just substitute the answer you got on expected value of x and put it there. So even variance is the same treatment. So like our question had variance of 4x. What did they mean? That rule. Just square the coefficient and multiply it by x. The coefficient is 4, we square it, multiply by x. The x value that we found from variance, because this is variance, we found 2.98. What answer are we getting at the end of the day? So what you can see on the screen there is the variance of that coefficient 4. Okay, that coefficient 4x. Just square the coefficient, multiply by the variance answer, and then you find the answer. So it's just the properties, the rules that play around probability distribution. So this video was a rather, let's say, application type. How do you solve questions on probability distributions? And this is the approach we take.